So I'm going to present so all of this actually happened with the DIGS acquisition. So we saw that there was a need for the DSPM space, and there was a hole that we had to look at CNAP from a very data-centric view. So we went back and said we would like to see who are the leaders in the industry. We said DIG actually does everything that we look for. We acquired DIG early last year or late last year. So first things first, right? I'll talk about the first primary use case, which is essentially onboarding and dashboard at the end of the day. There are different types of projects that is actually supported at the end. Like as I mentioned, AWS, Azure, GCP, primary CSPs that we actually support today. And then we have support for database as a service like Snowflake and Office 365 applications. So onboarding is really easy for customers where they can actually go in and add their entire organization or a single account by deploying a CloudFormation template. Essentially, that's actually going ahead and asking them permissions to read data stores on their access. As I said, within 48 hours, you'll actually see this dashboard populate. And what is this dashboard signifying or showing is an overall score, right? Doesn't mean anything initially, but essentially provides you a way to understand what is your posture score at the end of the day. And we look at it from a lens of what needs to be prioritized first. So the most important pieces you need to start prioritizing is your risk. Start with your incidents first. So I show you top risk that could actually increase your score in the right way. So there's data flowing out of production. There are sensitive assets that are open to the world. And then finally, the other one is around exposure. Once I'm done with my incidents, reprioritize, look at your exposure, understand what kind of assets are open to the world, what kind of external accounts are accessing or have access to your data stores. And then finally, cost conserving a little bit, right? Because we spoke about it early. Orphan snapshots are the main reasons of breach in majority cases. Reduce your data footprint. If there are empty storage assets that are running without any data, if there are orphans snapshots or shadow backups, delete them, right? So at a high level, the dashboard provides you with the view of what is your overall score and where does the data live in. But I'll go in depth of each one of them. So remember the first question we had from a CISO's perspective, where are all my data assets and what type of data do I currently have, right? So we immediately provide you a complete inventory of all the different data stores that exist today, which is, I could show you both managed, unmanaged database as a service. And let's start with the simple managed ones. It could be an S3 bucket, or it could be an RDS instance at the end of the day, right? I clearly tell you what kind of data store exists. So what is the bucket? It's an S3 bucket. Different labels. What is the encryption status? Is it open to the external world? And all the metadata around that particular object. Who's the owner of that particular object? What are the different tags associated with it? Somebody mentioned alert asset freshness early on, right? Because we have access to who has access and who's accessing the data store. So if it's a stale data store, you could then decide to either request the owner to terminate the data store. When was it last accessed? So at a high level, you actually get complete data in terms of how many files, what is the size, what are the different types of data types that exist. This is all based on the signatures that we have. I saw some credit card information. I saw some PII data on that particular file. You can even take a look at the file itself and say, these are the different types of file in that particular bucket, and individually look at a specific file and say, this particular JSON file, gzip file, actually has multiple data types. And for customers to evaluate and understand, if I tell you that this has credit card data, first thing is, how can you validate that? Right? Can you show me what in that is triggered as credit card at the end of the day, or what in it is triggered as an email address at the end of the day? We only store masked information. We don't get any real data at the end of the day to our product. Remember, everything gets analyzed within the customer's environment itself. So there's complete data that they actually have underneath. So that's the initial question of data discovery. So I can do this for managed instances, unmanaged instances. So for example, I can go take a look at an RDS instance. This is going to be a structured data store. It doesn't have files, but it has tables, right? I clearly tell you the owner, the same information that we were showing earlier, but the difference here is there are no files. But I show you a table in terms of what are the different columns. What is the size of that particular column? What type of data was found in that particular column, more specifically, right? So if somebody is exposing data accidentally in a database, we automatically detect it and tell you what data was found in that particular column.
Is there any sense of accuracy here? Like, I'm used to device posturing. I've not really looked at data posturing. When device posturing, you have like a percentage that you probability you got this right. Is that the same thing happening?
In our case, it's a regular expression match. It's usually a match is 100%. It's not ML based currently. So it's 100% accurate that we found that same expression match. Now, the question is, how accurate do you think it is to your business flow? As mentioned earlier, I could have test data. I could have test driver's license, and we've detected it as driver's license, but by the way, but it's false positive because it's mock data at the end of the day, right? That reduces the accuracy a little bit, but we typically don't have any written accuracy specifically.
Okay, so is there a way for someone to go in and say, yeah, this is test data that we don't worry about this. So, but each piece would need to be looked at individually in order to improve the accuracy of it?
It just depends. That's why we provide the data. So if somebody is looking at financial information or email address, for example, they can always go back and say, oh, but this data is mock data. I'd like to report this as false positive. So we understand that in our process that this is a false positive, so we can reduce the amount of alerts that we've created as a part of it, right? Remember, it's not always about just exposing sensitive data, but it's always about adding another critical risk element towards it, that it's either exposed or the data is actually moving out of a particular region, right? Together, it makes it critical, but yes, we allow you to go ahead and inspect if the data source was truly what you said. And if you think for some reason it was mock data, you could always report it back as false positive. So apart from the second part of the risk is around risk identification, right? Now that I know where all the sensitive data is, how it actually sits, the second part is identifying risk, where we call it in different ways. We actually call it risk and alerts, where each one of these data stores have a different prioritized risk laid out clearly. So you can go back and specifically either say somebody's investigating it or close it out depending upon the path. Misconfigurations could be on the config side, on the identity side as well. We provide you a clear understanding because identity is complex in this environment. We provide you a visual of what are the different roles that potentially has access to this particular data store, right? And based on this, the second question gets answered. Now that you've told me who has access to the data store, can you tell me who's accessing the data store? That's active identity. In combination, both of these are important because in the first one, you know if you're given a data store over permissive access. And in the second one, you kind of get an identity of, are there any events or threats that should be worried about at the end? So that was about managed data, right? Managed meaning I could probably have an RDS instance where I could spin up. It's easy to identify. I can go ask AWS and tell me what are the different structured data stores or unstructured data stores you have. We also show unmanaged instances. It's very common. During lift and shift of an application to the cloud, customers can actually take an existing on-prem SQL server, migrate it into the cloud. That's what we call unmanaged instance. Now, this is tricky. AWS can tell me if there is an EC2 instance, but AWS doesn't tell me whether the EC2 instance is running a database within it. We have the capability to go detect that, excuse me, that this particular AWS instance is running a MySQL, PostgreSQL server, and we provide the same information that we provided for a PaaS service. We have a secret sauce where we look at the instances and tell if it behaves like a database at the end of the day. And then we go inspect and apply the same mechanism where we look at the data within that particular instance. This kind of gives us more information on the unmanaged assets as well, which majority vendors actually pass out on. And then Snowflake automatically, where we're able to connect to a Snowflake service and provide the same information where we earlier shared. Empty assets. So let me look at something that actually has some asset at the end of the day. So we again categorize it into different columns that we've actually come across. What are the different data types that we actually found in each one of them, etc. So that's inventory from an asset perspective, right? Let's take a use case wherein the persona is different. I'm a data security persona. I come in as an organization, I have a specific policy that states I should not own any credit card information anywhere in our system. Our organization doesn't hold any PCI data at the end of the day. We provide this finding data type across to say that these are the different types of data types that we have seen in your organization. And let's say you want to take a look at social security number or credit card number. I'll specifically focus on social security number, right? I can clearly see that I have 1.8 million social security records that we've actually seen across the globe, and we specifically map where we have seen this data. Now, in some cases, you can come by and say, it's okay for me to have it in North America, but what are the data sources doing in Frankfurt? I can take a look at what are the different data sources that are actually deployed in Frankfurt that actually have it. I can take a look at the files specifically to say there are specific files that actually have been implemented that have social security numbers. It's just an Excel sheet. You could potentially go ahead and have the owner delete the Excel sheet, say that for compliance reasons, I should not have those social security numbers in an EMEA region. Similarly, you could do the same with the other aspect. If there are PII data that's specifically related to EMEA, you'll be able to see all the data sources that are actually mapped across your globe. Right? So this is primarily a use case for more of a data security admin, where they have organization-wide compliance that says this particular type of data should not be exposed or should not be stored at all. Right? Easy visualization, easy storing at the end of the day for customer to go back.
Earlier on, I think you said that part of your risk assessment was whether the data was encrypted or not.
Yes.
Is that shown here at all?
It's shown in every case. So when you look at any single asset, we provide the status of encryption and the exposure of the world as well. So this is what we call a configuration on a particular asset, right? If I deploy an S3 bucket in AWS, I can either encrypt it using a native key at the end of the day, and I know immediately that it's actually encrypted by that particular standard. When I go to risk, what we have done is out of the box, we've actually put it out as risk, right? If it is a sensitive asset that is open to the world, it's a high risk. Similarly, there are encryption pieces as well that are actually pushing out data sources with no retention policies, sensitive assets that are not encrypted. I can specifically look at that and say, oh, I have two assets that have PII data and PCI data that have not been encrypted. So if I have an org-wide policy that says all data assets that are sensitive and defined by these sensitive types should be encrypted, this will automatically trigger an alert for you out of the box.
And do you show how it's encrypted?
In cases, because we're looking at cloud, we are able to look at it. So for example, in this particular case, it is unencrypted and it is private. But if it is an encrypted database, let's take a look at a database that's encrypted. This is unencrypted too. So we'll be able to specifically tell you it is encrypted via a cloud native CMS key at the end of the day, right? We'll talk about external encryption at a later point in time. So there are two different types of, you could use cloud native keys to actually encrypt your data store, or you could bring in third-party HSM keys to go encrypt your data store. So there are different subtle differences in the way that who has access to the keys and who don't. In our case, we do request for any cloud keys in order to decrypt the data, analyze the data as well.
Okay. Okay.
So going on to the second part of the risk, which we kind of did early on, there are out-of-the-box policies that we actually showcase where we show different findings across the risk. And I said early on, we do allow you to customize these findings as well, which is if I have a policy that says I'd like to go ahead and detect all developer secrets that are exposed, I can write a policy specifically that says, look, I need all the data labels that show developer secrets and is public. Risk type and everything else that I can actually add in. So immediately get a list of all the assets that actually have secrets. The second reason of breaches from majority of databases, right? Unencrypted secrets or open secrets that are actually plugged in and are on GitHub or on different buckets anywhere else, right? Attackers get access to these secret keys and essentially access the database from there. So it's been a common practice for a lot of vendors to go detect these secrets across different asset types. And DSPM or DIG actually does it across different data stores. Could be an S3 bucket. It could be an RDS instance where somebody's plugging in these secrets in a column. So after risk, we kind of dive into the DDR policies. These is what I called early on threat policies that we have. Right around, we have 21 different threat policies that move to reconnaissance that talk about, has anybody made the asset public? Were their storage versioning disabled? Right? Any attacker that is trying to get access to the data would probably go ahead and disable logging, disable storage versioning before they get access. So this is what we call first move at the end of the day. It could be compliance, simply. Either data transferred out of Europe or data transferred out of a production asset at the end. So those are important for us to go look at as well. And then all the risk that we identify gets as threats that we identify goes in as alerts. So an admin can actually look at and say, production data asset deleted. Why did anybody delete a production data asset? Let's go take a look at that particular detail. You clearly see, when did the event actually happen? Who was the actor in this particular case? A user, what was the user agent actually used? What kind of MITRE framework did it actually come down to? Now, in order for somebody to investigate, they kind of go in and say, can I see what's happening around that particular asset? What else did that particular actor do? And what were the other events associated with that particular event? So a lot of times forensics is kind of important because you want to know what happened before and after a particular threat is actually exposed. And then finally, a raw event. Where did we get that event? For somebody to analyze this further to figure out more data. And it could be a user, for example, in this particular case, that actually triggered that data movement. It's an assumed role in AWS. You specifically say, what else did the assumed role actually do? Create a table and delete the table. Right. So as a part of the investigation post that process, you can either say, hey, this is in process and investigating. So somebody is actually looking at it as a SOC admin, goes and looks at it and says, what are the next steps in terms of response? Or it was a false positive, right? That event actually had to be generated because it was a legitimate event. It's a benign event that was actually ran. So it is unimportant or wrong, or it's been handled. Because handled meaning I've accepted the risk. I spoke to the admin and said it was a benign event, accidentally clicked on a particular asset that they were not supposed to, and nothing was exfiltrated or no data moved. We've looked at it. We've actually gone ahead and calling it out as risk accepted. So those are the things at a very high level they kind of bring in. So remember those three questions we kind of went through again, kind of answer those. Now, the most important, coming back to your question early on, is how do you showcase that within Prisma Cloud? So one, within Prisma Cloud, we've introduced a new persona called data security, where within the UI, everything comes together. Two, the biggest thing that we are actually trying to bring in is today we have these concepts of attack paths. I don't know if you can actually see it right now, but here in this example, as I was stating earlier, what we are looking at is an EC2 instance that is internet exposed, and we tell you what are the means it's actually internet exposed. How is it internet exposed? What are the different vulnerabilities we found on that EC2 instance? Which means it is still a risk and a vulnerability. But I actually see some threats. Threats are real-time incidents or events that are happening. We have agent-based system which can actually detect SQL injection and code injection. These are real-time events that are happening on that instance. Plus, we have an AI model that actually detects threat and tells us that there's unusual volume of data that is actually being moved in through using that particular EC2 instance. So combining these risks and threats, we kind of narrow it down and understand that this particular data store is connecting to an S3 bucket. What's missing here is what DIG actually provides on top to say that this particular data store has sensitive data, and you need to look at this entire attack path as a critical P0, because they're not only risk, but open events and threats that are happening. There's even access to the data that has been provided. So you can investigate with DIG further to understand, which we call DSPM, to say, understand the context of threats on the data store, data on the data store, events on the data store at the end of the day, right? Bring all of those together to provide that context to the cloud security admin, so they can actually prioritize this event in a few seconds.
So, Ben Story here. You briefly touched on an agent when you were talking about the EC2 instance in your example there. Is that on the EC2 itself, or is that some sort of agent in AWS? But kind of
Good question.
clarify what you're doing there.
So Prisma Cloud has several different modules. So we have a module called Cloud Workload Protection, which has an agent-based and an agentless approach. So an agent-based approach provides you both vulnerability detection and real-time threat detection and protection. So it has a vast module built into it, an API proxy built into it at the end of the day. So we're actually looking at all the traffic going in. So it's an agent that actually sits within the EC2 instance.
Okay.
That's providing you real-time protection. That's why we don't talk about just detecting risk, but also being able to protect you from actual risk through these events, right? You could have the SQL injection web attack where the WAS event has actually discovered it. You could have had it in a block mode where we would have not only detected it, but blocked that particular request as well. Okay, any questions so far?
In the module where you detect that there's an attack, the recommendations for preventing that, where do those recommendations come from?
So with we'll specifically focus on data more so, right? And if we detect a particular attack, there's two contexts to it. If there is an incident or a threat, the recommendations are different. So we don't have different recommendations for threats more specifically in this particular case with DSPM. What we have the SOC admin do is investigate further to figure out what are the next steps. And typical next steps is to go ahead and reach out to the admin and understand what are the different ways to mitigate that particular alert. You're either accepting the risk or you're mitigating it by disclosing how further did it actually go. But this actually is a good question because we want to think about what are the next recommendation with Prisma Cloud. We can take it offline and we can talk about different ways we can actually recommend or remediate a threat directly using our other modules, right? With the risk context of risk, for example, it's different. So for example, if it is an open asset to the world, we provide you with steps on how to remediate it. This could be as simple as reduce exposure or disable internet exposure, or it could be enable logging in specifically for that particular asset, right? So we have very specific remediations available for risk. And in case of data, for example, It could differ from organization to organization. It could be, if the example that I took early on, which said that I'd like to go ahead and detect PII data, because I'm not supposed to have any PII data across the globe, your remediation would potentially be to go ahead and have the data admin delete the data store, right? Or delete the data object more specifically. One final thing that I wanted to bring in as a part of DLP is we have a use case where it's not only readable data, we're even traversing into OCI, for example. So let's say I have a use case where customer uploads driver's license and other identification number, would like to go ahead and detect if somebody has uploaded a DL photo or an image of a DL, a PDF or JPEG at the end of the day. So I can specifically look at databases and data stores. Let's say I want to always do it publicly available. I want to know all the sensitive data objects that are publicly available. So I've seen some driver's license in these cases. So I can specifically go back and take a look and say, I found a driver's license with street address, and this is not based off of a text file, but it's actually based out of an image. So we have object character recognition that I can actually recognize images in PDF and JPEGs at the end of the day to say that we've actually found sensitive data. Not only now, earlier, as I mentioned, it was a pattern recognition, but in this case, it is an OCR pattern recognition at the end of the day. Right? This is important because I've had customers come in with, I don't even have text files, but I have images. People are expanding into audio files and video files as well that could potentially have sensitive data.
Ask the German government how they feel about that.
I was even thinking in healthcare, you know, as you migrate to digital records, they take the old folders and they scan them into PDFs and images, and it becomes, you know, it becomes an image. It's not.
It's no longer a text file that can be
It's
read.
not something that can match in a regex. It's something OCR or something else has to
Absolutely.
look at.
So I guess the next question is, you're OCRing these files as they go up to look for PII. What are you storing from that OCR? You're not actually.
We're not storing any data. As
You're
you
just looking for pattern matches and alerting that there is a pattern that's matched.
Yes, exactly.
Because that's a whole of, well, now I'm storing data that shouldn't be stored.
Exactly. So the example that I showed you earlier is because I was able to detect it was a public URL. It's not only stored, but it's publicly available. And here's the URL to it. So we don't actually store any part of the data.
But what you're storing in this case is like that samples data over there that you're looking for.
That's the
this
masked
pattern. Okay.
Correct. So we found masked patterns of this data. So by the time the data comes to us, it's always in this masked format. We never get real data. And the example that I showed in earlier, the image of the driver's license was only because I was able to get to the actual data via the URL.
Vinayak, can you answer the question? Does the data leave the customer's environment?
No.
Can you detect on variations of a pattern?
Give me an example of that.
Social security numbers are 9 digits.
Yes.
If I wanted to obfuscate the DLP system, maybe I change where I put the dashes to make it look more like a phone number, even though it's not actually what it is. Can you guys detect that variation?
So there are dependencies where you can actually custom create a pattern more specifically to say this is what you need to detect. Yeah, out of the box, it is what we have in terms of pattern matching. But there are custom patterns, as I said, the earlier example around customer requesting VIN numbers more specifically was a good example to say I'd like to discover all the VIN numbers across my organization.
Because for a car company, it's PII, but for me, I don't care.
I don't care. Exactly. Yeah.
What about
Right.
So
what about other SaaS applications like Atlassian, as an example, Confluence or Jira? Can you scan those?
So today, as I said, our primary focus is actually cloud, but we are expanding into some SaaS applications with the footprint around Office 365, right? So there's an DSPM as a market is expanding into both cloud and SaaS, some into on-prem with network file share and other services. So we are definitely expanding in that particular sense in that particular market. So we'll take it offline because there's a little bit of an overlap with Prisma SaaS as a different product that actually focuses their CASP efforts on SaaS applications. And
So actually, I just want to rewind real quick to kind of what Tom was saying about information that goes to you guys. So I think on that screen, it did have file names, right?
yes.
Okay. Because what I've seen before in unfortunately production environments is there's times where files will be named with PII or PHI or both inside of that name. So I guess, how do you guys, are those one-to-one where you're taking that data and you're actually storing it in your system? And if I had that record, would that then be transferred to you,
It
or?
would be. So unfortunately, in this case, what we call is metadata at the end of the day, right? The file name by itself or labels that you might have actually put as a part of the particular file.
Mhm.
If they contain sensitive data, we don't look at that metadata more specifically. We disclose that metadata, which means you see all the metadata in terms of what is the application, what are the different labels associated with them, the asset ID, the user that created it, because user technically is PII at the end of the day, but we have that information as a part of metadata.
Mhm.
We disclose that to say that these are the user information that is already out there,
Mhm.
and we would be ingesting that data and showcasing that, but we would have no data associated within that particular file.
Yeah, I guess I'm more thinking of the use case where I'm less concerned about the PII from like the employee perspective, right? It's more if I'm, say, production healthcare and I have a RDS instance that you're scanning and you're ingesting, or well, that's a bad example, but S3 instance where I have file names in there. And those file names end up containing that PII, PHI in it, where it's not necessarily my employee's information, but it's possibly a client's information. How do I make sure that that data in itself is secure and not at risk? Or is it something where I need to look at a BAA?
Yeah, that probably be a one-off. We will have to take a look at and see how do we actually not disclose that information within the product.
Mhm.
Because today we actually list out all the file names more specifically that are listed.
Gotcha. So
If
that's
it's
not
an accidental disclosure that I put some credentials of my customers within as a file name,
Mhm.
we'll have to figure out how to mitigate it.
That's not like a button that I can turn off, though.
Exactly.
Okay, gotcha.
Okay, so I'll leave open time for some Q&A now, or unless.
If you don't mind, I'd like to poke that one more time. You've gone over running regex over data for matches. What if my data is the file name? Like what if I have 1,000 customers and I take their social security numbers and I create the file name as the social security number and it's 0 bytes of data?
It's still some data at the end of the day.
Matching the regex on file names or only the
data?
Only the content?
Today we're only looking at the content more specifically, right? I mean, we could definitely take that offline and then discuss in terms of how we can expand it within the file name as well, but we have not come across customers that have used those or done those in the past. But clear example, if there is such an incident, we could potentially do that.
Wouldn't you also assess how is that storage configured, and is it configured properly as well, wherever you're storing that file?
Yeah, but that's just a file name at the end of the day. Yeah.
Yeah, that was something I was going to talk about, where you have to feed this thing decryption keys in order for it to look through encrypted data stores, right?
Correct.
So in a case where it fires on finding PII, is it intelligent enough to know this is already stored on an encrypted volume?
Yes.
So normal people wouldn't be able to see this. So I'm going to lower the priority on the alert and maybe just give you an informational notice.
Exactly. Absolutely. Right. That finding would actually change now, because even though the file is public, it is encrypted. So it'll be a lower risk at that point in time. It's still public at the end of the day, so people can get access to the file. That's encrypted.
But if I have it encrypted with something like file,
and that's why we disclose all the asset detail. So what happened? Is it encrypted? Now this is kind of lower. It's open to the world, but all the files are encrypted at the end of the day, right? So my alerts are in some cases the asset is made public by itself is high, where we could take that and correlate multiple ones, which is what Prisma Cloud actually does at the end of the day. Looks at encryption, looks at alert, looks at the other context that actually gets created with it, and gives a score to the risk that gets associated.
So you've got all the data because you're diving into the cloud and getting all this. Do you have a way to visualize it for the CISO or otherwise to see like a visualization of data flows through their environment?
So that's a good question. So there are products that specifically focus on data um, flows at the end of the day, which application consumes that particular data, how does it actually do? Today, where we stop is essentially we take a look at the data and then go, this is where your data is stored,
Okay.
right? Something that we can consider in future if data flow is important.
Yeah,
Depends
I
on the
wasn't sure
persona.
if you'd integrated like with Prisma to see, to show all the,
Something on our
you're,
roadmap for us
I
to
was,
think.
I was gonna say, you've got all the info, so
Yeah.
just visualize it would be awesome.
Yeah, absolutely. So we have the context of what application. Remember the AI example that you actually saw
Mhm.
would show what application is consuming the AI model and what AI module is consuming from a data perspective. So that's a flow that you would actually
Right.
see.
That's what kind of tripped me to say, hey, let's take it to the next level, because
Correct.
that seems to always be the visibility issue for a lot of companies is they know the data exists here, they know the data exists here, and then when you ask them, well, how's it getting from point A to point B, or which application's using it, they just kind of look at you and go,
I don't know.
eh.
In majority of the cases where we are actually starting off from a product perspective is actually discovering the application itself. That's where we're starting out, right? To tell you that these are the applications that are actually on your cloud infrastructure. In majority of the cases, cloud admins don't know what applications. They're basically looking at all of these instances and say, what are the risks? But they don't know what does it correlate to when it goes to an app. Is it a business critical application? Or is it a website or a web app that is externally facing marketing app at the end of the day, right? Those are the important pieces that we're actually filling out as a puzzle before we go into the data flow, the back end.
Awesome.
Because we have all the context, your
Exactly.
code that actually tells you where it's deployed, how it's deployed, your APIs in terms of how they're actually connecting. We're figuring out and visualizing what does the app look like, then what are the different context of the apps that are available as a part of it.
Anyone else?
No, I don't have a question, but just as a matter of opinion, pretty cool. It's pretty unique. I've never seen another product like it. I don't have expertise in this domain of data protection, so to speak. I almost
Yeah.
feel like after seeing this, it almost needs like its own domain, its own type of engineer, someone who's going to evaluate this product alone. Because I feel like there's a lot of facets to data protection, understanding if you have it to follow any compliance guidelines and what data you have to protect and in which ways, whether it's healthcare or finance or PII records. I mean, I'm just a network security guy, so that's something like I wouldn't know how to wield the sword, but this seems like very cool and I don't know, I like it. Neat.
Awesome, good to know.
I have a question. If you go back to the very first slides that you presented, and you talked about 2.8 million unique monthly vulnerability findings, does that relate to this product, or is you talking more?
No, it's the broader
It's
Prisma
the
Cloud
broader
product that
picture.
we
So how does this product fit into some of these things that you talked about right at the very beginning?
Yeah. So it's obviously this is a count that was taken snapshot and no, it was like last month or last 6 months ago in place and there,
Right.
right? But it's an ever increasing count. Adding the context of data increases our ability to consume more data events at the end of the day, right? We were earlier only looking at data write events. Now we're looking at data read events as well, right? So it increases our ability to consume more data, events being processed from 1 trillion. As we increase the number of customers, that's going to expand as we see. And the ability to detect threats is also going to increase as we actually see, because not only we're looking at just events from an asset perspective, but from a data perspective as well.
So I guess my question is, I was looking at the unique part of this, the question, is there something that this tool is giving you that makes Palo Alto capable of creating or having insights into vulnerabilities that other companies can't? And does that fit into this 2.8 million number? That's what I was trying to get at.
Got it. I mean, from a vulnerability standpoint, again, as I mentioned early on,
Mhm.
those vulnerabilities kind of narrow down. So when I look at a vulnerability and go, you have, let's say a customer comes up with Prisma Cloud and says 5,000 vulnerabilities.
Mhm.
right? To start off with, there's no way they're going to tackle that many vulnerabilities in a quarter, or 6 months, or a year for some cases as well, depending on the size of the team. But where we start narrowing down is as we go down the list, we specifically say we found 5,000 vulnerabilities, but out of them we found that 100 of them were actually externally exposed and and you could remediate. Now even filter that down and say that out of those 100, I found out that these vulnerabilities were either on data stores that are sensitive or are connecting to data stores that were sensitive. Maybe 20 of them come up. So you could create a narrow down from 5,000, you go down to 20 vulnerabilities that are on data stores that are sensitive or connecting to data stores that are sensitive that you could remediate. Now you can actually fix those 20 in a specific amount of time, let's say a week's amount of time, depending upon the SLA that you provide, rather than going around with 5,000, which you wouldn't know how to prioritize, where to start from, how to go around. Right? That's exactly where we're coming down to. 2.8 million unique vulnerabilities across all our customers. If we talk about individual customers, they probably see 5 to 10,000 vulnerabilities each. Right? Bring that down, narrowing down is very important for us, for a customer to give them, these are the prioritized vulnerabilities that I would like you to focus on. And data is one of the lens that we look at those vulnerabilities.
And you can see that with your dashboard as
Yes.
part of your demo, you can actually narrow into that. Okay,
Yes.
great. Thank you.